Hello and welcome to Absolute Value Inequalities, Day 3. So we're going to be solving and putting numbers inside the absolute value, outside the absolute value, and graphing and checking to see if we have a solution. So our first problem here is just recalling, because sometimes when we don't do these basic ones for the beginning, we kind of forget how to do them. So if it says absolute value, symbol, number, we can go set up our two cases right away. So we have x is greater than 7, and then our second case is x. Remember, we're going to flip our inequality sign, and we're going to make this be a -7. Now, there's nothing for us to solve, so we can just go to our number line, put down 0, and we have the number 7 and -7, and neither one of these have lines underneath, so they're both going to be open circles. And this first one here is read, any number is greater than 7. So greater than 7 goes to the right. And the second one here is read, any number is less than -7, and -7 goes to the left. Now let's just go back and assess it from the beginning. This is a greater than, and we have said a greater than is like an or problem. And when we graph them, we're going to be shading out. So isn't that exactly what happened? Greater than's like an or, and in our compound inequalities, these were shading out. All right, keeps forwarding too. All right, second problem. We have absolute value, symbol, number. So that means we can go right to x plus 3, the symbol less than or equal to 8. Okay, and then the second one, we've got x plus 3. And now remember, we're going to flip this sign. So we have less, greater than or equal to, and make it be -8. All right, now let's solve this. Subtract 3, subtract 3. So any number less than or equal to 5. So on my number line here, put down 0, have my 5. It says less than or equal to, so it has the equal to underneath it. So I am going to shade this in. And any number is less than, so I'm going to shade to the left. On the second side over here, I'm going to subtract 3, subtract 3. Make sure you guys are using your calculators so that we do -8 minus 3 on your calculator, and we get a -11. So over here we have a -11, closed circle because it says and equal to. And if we read it from the letter, it says any number is greater than or equal to 11, so we shade to the right. And when they're overlapping like that, remember we're going to go down and shade it between. So if we go back and assess from the beginning, this is a less than sign, which we've said is like an and problem. And problems shade between. All right, number 3. So let's just look at this. This is a greater than or equal to problem. So that's like an or problem. So when I am all done graphing, my graph should look something like this. All right, so I have this number right here, this -5. So it doesn't say absolute value, symbol, number, that 5's in the way. So I'm first going to move this 5 away. So it's absolute value of x plus 3 greater than or equal to, and 9 plus 5 is 14. Now it says absolute value, symbol, number. So I'm going to set up my two cases. The first case is going to be exactly like you see it without your absolute value. And remember, the second one is going to be x plus 3. Now flip your sign and make that be -14. Okay, now we're going to go ahead and solve, and we're going to subtract 3 from both sides so that we have x is greater than or equal to 11. So on my number line here, put my 0, have my 11. It has an equal to underneath, so we're going to have a closed circle here, and any number is greater than, so it's going to the right. And on the second side over here, we're going to subtract 3, subtract 3. Again, please remember to use your calculator so you get this math right. Negative 14 minus 3 is a negative 17. So I'm down here at negative 17, closed circle, and we are going to shade to the left. All right, let's see what happens. It's an or, shades out, and I got it shading out, closed circles, because I have the line underneath it. All right, now we've got two numbers in my way. So absolute value symbol, but I need to get rid of this 3, and I need to get rid of this negative 12. And in our order of operations, remember, we want to do it backwards. So we want to take care of this plus 12 first. So I have 3 and then the absolute value of x plus 5. Leave my symbol because all I did was add, and this is a 27. Now this says 3 times something, so the opposite of times is divide. So we have the absolute value of x plus 5 is greater than 9. 27 divided by 3 is 9. Now it finally says absolute value, symbol, number. So I can write my two cases, x plus 5 greater than 9. Now remember, in my other case here, I am going to flip that sign and make it negative 9. So subtract 5, x is greater than 4. So on my number line here, got 0, 4. This is going to be an open circle at 4 because there's no line underneath it. It just says greater than. So we're going to go to the right. And in my second case over here, I'm going to subtract 5, subtract 5. Please use your calculator. So when we take negative 9 minus 5, we get a negative 14. Now we have an open circle because we do not have a line underneath it, and x is less than 14. So if I all of a sudden start graphing it and go like that, something in my brain should say, wait a minute, those are not the two cases. Our two cases are they either both go out or we shade between because they're going toward each other. So when these are both going the same way, I know I messed something up. And it just so happens that it's this one that I messed up here because if I read it from the letter, it says any number is less than, and less than goes this way. So now I feel a little better because it's shaded. They're both going out. So that's the way we want it to go. All right, two more problems. We've got this one and one more. All right, I don't see a number after, but there's a number in front, so I have to get rid of that first. So I'm going to divide both sides by 4. So the absolute value of x minus 2 is less than 5. So we have x minus 2 is less than 5, and we have x minus 2 is greater than, flip it, and negative 5. So we're going to add 2, so I have x is less than 7. So on my number line here at 7, is it going to be open or closed? And it's going to be an open circle because it has less than, no sign underneath it. So I'm going to have an open circle, and that says any number is less than 7. So it goes this way. All right, in my second one over here, I'm going to add 2, use your calculators. So we get negative 5 plus 2 is a negative 3. So we're down here at negative 3, open circle, and shading to the right. So these are crossing, overlapping. So we want everything between the numbers negative 3 and 7. So now if I just ask, is 8 a solution? Is the number 8 right here an answer? And the answer is no. Is 0 a solution? Okay, is 0 in that shaded region? So the answer is yes, it is in that shaded region. So now if I take, is negative 3 a solution? Well, let's see, it goes up to 3, But this is an open circle here at -3. And because it's open, no, this is not a solution. We're going up to -3, but we're not including it. All right, so here's our last one. They want to know, is 5 a solution? So there's a couple different ways that you can do this. One is you guys can graph it. So we could just totally solve this, divide both sides by 5. So we have x plus 3 is less than, and when I divide this by 5, I get 7. So now I have x plus 3 less than 7, and x plus 3, remember, flip, and -7. So now I'm going to subtract 3. So x is less than 4. Open circle at 4 and shading to the left. Subtract 3, subtract 3. So x is greater than -10. Open circle, shade to the right. So it's everything between -10 and 4. So is 5 between -10 and 4? No. So this is not a solution. Now, that works best for some of you, but some of you just want to take this number, this 5, and you just want to plug it in here, and then you want to do your math. So we're going to do inside this absolute value first. So 5 plus 3 is 8. Okay, then we have 5 times the absolute value of 8. Well, the absolute value of 8 is 8. 8 times 5 is 40. Is 40 less than 35? And the answer is no, so we still get not a solution. So you can choose to graph it, or you can choose to just plug it in and then see if you end up with a true or false statement. And if it's a false statement, the answer is no, not a solution. All right, good luck on your homework assignment. It is on Schoology, so go ahead and give that a try.